All right. Good. Is it good afternoon? So we are going to. I was beginning to wonder if what had happened last last week was happening again. It appears it is. So we're going to continue our discussion of. I believe it's module number two or something. Is it number two or number one? Module number two, I think it is. And we had gotten to a stage where we. I can just find what I'm looking for. We had gotten to a stage where we had started looking into so-called. I think it's actually module number three. We got into a stage where we were looking at computer software. What we realized was that there's really there's something really interesting about software, right? The fact that but by the way, sorry, if you could maybe just help confirm if you can hear me, and also if you can see my screen. Hello. Hello. Can you hear me and can you see my screen?
Yes, we can hear you and see the screen.
Thank you very much. All right, wonderful. So we started our discussion of application software, and what we did was we first of all contextualize, right, prior to our our discussion of the two broad categories of software, it's application software and system software. We had a brief overview of what software is all about. Now, I just want to quickly take you back and remind you to say we realize that an application like a social protection management information system such as this piece, all right, social protection management information system such as this, which is this piece, is created, okay, by human beings, is it? So they write instructions, okay? They'll write instructions using what's called a programming language. And the programming language is nothing more than a set of symbols, if you will, right? Or a set of instructions which, when combined together, will result into what we call software, okay? Something else we realized was that before a piece of software like this can actually be actualized, there are a series of activities that need to be undertaken. And specifically, I'm referring to the process which we said is loosely tied to what's called the software development life cycle, right? So this notion that the very first thing that you need to do is you obviously need to gather requirements, okay? There are all those phases, if you remember. So you undergo what's called requirements engineering or requirements analysis, specification, software design, there's implementation, then you have to test the software to see if it conforms to what the clients are expecting, and then finally the software will evolve, right? It will be continuously updated. This could be, bug fixes, as they are called, or it could be security patches sometimes. Okay. So quite a bit there, right? And we also made mention of the fact that when instructions are being created, there's different types of instructions that can be used. There are what are called high-level programming languages. There's assembler language, instructions, and also machine code, right? Ones and zeros as they're commonly called. But anyway, so, and then we broadly distinguished application software and system software. So we realized that when we are interacting with computer systems, it's your phone or your laptop or your desktop computer, what generally happens is you are implicitly, as you are clicking those buttons on your screen and typing on the keyboard, you are telling the hardware what it should do on your behalf, okay? And collectively, what it should do on your behalf results in maybe the screen being refreshed so that you see a completely different interface, for instance. Quite a bit of complex stuff that happens, at a very low level here. But the takeaway point really was that for the most part, end users will use application software to tell the hardware what to do, and application software does not really interact with the hardware directly, so it goes through what's called system software. Okay. Anyways, and then we briefly looked at, not briefly actually, we started our discussion of application software and realized that the things that we use as software on our computers, the application software, the things that typically used to perform specialized tasks, come in different forms, or there are subcategories associated with application software. So we have mobile applications. Okay, if you have your phone, the things that you find yourself downloading from the App Store. Okay, and then you have still a breed of, I guess, mobile applications would be your usual mobile browser here, and also USSD based applications. So these services, software services that we interact using USSD codes, they're called. So things like *114#, you are actually using software, right? Although in a very different manner, you type in responses using your keyboard, your virtual keyboard on your phone or something. Anyways, and then we introduced this notion of desktop application, and I think the vast majority of us are very familiar with desktop applications, right? We realize that for the most part, desktop applications need to be downloaded from somewhere before they can be installed, right? Once downloaded, you would typically execute that downloaded file, and then you go through a series of prompts where you agree to the licensing, agreement, and then give the piece of software permissions, right? Anyway, and then you can then start using your application. But in addition, what we realized was that we increasingly there's this new type of desktop applications. Okay, applications or software that don't necessarily have to be installed. So you download it and then you can use it right there and then without really installing it, right? They're called portable applications, in part because you don't have to associate them with system files on your computer. You can actually run them off of like a USB stick, for instance, okay, or an external drive, if you will. Very, very useful. Although there are potential risks here from a security perspective. Anyways, and then we see here that there's also so-called web-based applications, right? And these are mostly, when we talk about web-based applications, these are applications that you typically access using your web browser. Facebook, Gmail, Google Drive, Google Calendar, all of these are web-based applications. And really, the name web-based gives it away, is it? You access this application via the web, okay? You need internet connectivity before you can access that piece of software. And for the most part, these web-based applications are available to us as a software as a service offering. Not all the time, but in most instances, because it turns out that there are instances when you can access a web-based application that may not necessarily be a software as a service application. Like for instance, those of you who have, I don't know how many of you subscribe to maybe Liquid Intelligent Systems, or Liquid Telco as they used to be previously called, or if you have a dongle or something. If you purchase a dongle, it's a router, really, that's a technical term, and you go through the instructions, they'll tell you to say, well, you can change the password and you can restart the router by going to 192.168.8.1 or something. It turns out what you're doing is, when you access this, I'm accessing this well, of course, I'm connected to the internet, but this is on my personal um, area network, right? So my laptop right now is connected to the router, this CEC Liquid Huawei 4G router, and for me to access or to interact with the router, I use a web application. Okay, and what you're seeing here, right, is what I'm using to access the, and I think this is the one here. I don't know. And when I log in through to that, I have access to a broad spectrum of features, right? I can choose to restart the router, right? If, let's say, I'm having difficulties accessing the internet, for instance, I can create a dedicated APN for visitors if I receive visitors and all those things. But anyway, the long and short of it is that I am accessing a web-based application, not necessarily via the internet per se, right? I'm accessing it locally here on my local area network or my personal area network, if you will. I just want us to, kind of dispel this this misrepresentation that a web-based application can only be accessible over the internet, or it's available to us as a software as a service. This is not always the case. Okay, and then we realize that you see, interaction on the internet. What makes the internet interesting is the fact that, or the essence of the internet or the web, okay, as is sometimes referred to here, is to enable exchange of resources, right? Like it or not, you're interested in the internet because you want to exchange messages, right, with your loved ones or friends or something, right? You want to gain access to resources, notes, videos or movies or something. Okay, now that raises a number of interesting concerns, right? Because whenever we are referring to you are interested in something, you're interested in something, the assumption is always that the you is a human being. Or it turns out that there are certain things that happen on the internet, right, that are automated. So they happen, or the exchange of data and information is between computers. Okay, so we can just view that interaction as being interaction between autonomous computers or something. So they'll be exchanging data. Of course, that exchange is initiated by something usually, right? A classic example I like giving that you can easily relate to is, I don't know if I mentioned this with the class really, but single sign-on, right? In most instances, you have applications like what I'm about to showcase here, right? Applications which require you to authenticate yourself, so to supply a username and password. And increasingly, there is an option for you to not really type in your email address or username and password, but you can use what's called single sign-on, right? So you can log in with credentials associated with a completely different application. Like in this particular case, I am using Stack Overflow, but Stack Overflow is telling me to say, well, I can either log in with my traditional email address and username, email address and password, or alternatively, I can log in with Google. And the reason why there's this option to log in with Google and perhaps even Facebook, I'm not sure how many of you are familiar with GitHub, is because these are some of the most widely used services. I mean, the average person, if you are to interact with the average person in Zambia, no likelihood, maybe, I mean, if I was to make an educated guess, maybe 9 times out of 10, those people that are on the internet, 9 times out of 10, that person will have a Google or a Gmail account. The same applies for Facebook. This is why most applications will have these options, right? Log in with Google or log in with Facebook or something, if that makes sense. Now, this is possible because this application I'm accessing, Stack Overflow, can speak to Google services or Facebook, the Facebook application, or rather, it can exchange information. Now, this exchange of information is being done by two separate applications, software services in essence. And generally, these software services are referred to as web services. Okay, they facilitate what's called machine-to-machine interactivity. This is the reason why, if you find yourself on platforms like, I don't know if we can look at Lusaka Times here. If you go on platforms like Lusaka Times or maybe Mwevantu or something, don't know. Not the Mwevantu Facebook page, but the Mwevantu website, right? Mwevantu News, they call themselves. If you access one of the, I don't know how many of you have noticed this, but if you interact with other people, let's look at something popular here. There's nothing scandalous I can see here. Usually it attracts a lot of comments, right? And this is bad as well. It appears they've stopped doing this, but you may not realize this here, but, and this is a bad example. I wanted to see something that has I want to see something that has Facebook commenting activated or something. And it appears it's not the case. Anyway, maybe later or something. They've probably switched off commenting here. I'm wondering why this is the case. Let's see if I can think of, don't know what is happening here. So I wanted to showcase the way commenting works, right? And unfortunately, it's not here on Mwevantu, or maybe Zambian Watchdog. Let me see. I don't know if their website is even still active here, because ZambianWatchdog.com was increasingly a platform like Facebook has become more or less like the go-to place, right, when you want to do things here. I hope this works. But either way, as we're waiting for Zambian Watchdog, right, if you look at Lusaka Times, for instance, you may not realize this, but the comment section, right? Lusaka Times it's a WordPress powered web application or website. But what you notice in the comment section is they use discuss, right? I think it's discuss. It is, yeah. They could, I don't know. They should use discuss something. I don't know if it's a Gravata platform really. Let's see if we can find. Oh wow. This is even gone. That's okay anyway. I wanted to demonstrate how commenting works, and I can't really think of another popular Zambian blog that uses commenting. Okay, that's okay. Anyways, so maybe I can use my personal blog perhaps as an example, or we can just roll back to, it's okay, we can just roll back to, it's okay, we can just roll back to what we're discussing, right? The fact that you have this, right? So this is a classic example of two systems speaking together or exchanging data, right? And all of this is facilitated by web services. In the background, what generally happens actually is, and maybe I can showcase part of this. In the background, what generally happens is when there's exchange of information, because the entities that are exchanging information are software systems, they wouldn't necessarily want to exchange that information the way human beings and computers interact, right? Where you're clicking buttons. Okay? If you go to the Lusaka Times website, for you as a human being, the thing that you're interested in is you want to know, there's a title here, right? UN experts say Zambia to halt infringement of fundamental freedoms, right? Whatever that is here. And then there's some bit of text here, there are images, right? This to you and I, this is an appropriate way of presenting information. But when two systems are exchanging data with each other, the situation changes, right? The interest is mostly on the data itself and the structure of the data. So as a result, these so-called web services will look like what you're seeing on the screen right now, and I'll use pretty print here. It's structured data, okay? And really, the systems would be implemented in such a way that the exchange of data could either be one way, right? In this particular case, maybe we would say Stack Overflow gets information from Facebook for single sign-on. Or in some instances, it could be a two-way communication where both Stack Overflow and Facebook exchange information. So information is sent by Facebook to Stack Overflow, and Stack Overflow sends information to Facebook as well. Okay. Anyway, and so the information that would be shared is something like this. And true to that, if we were to search for UN experts, I don't know if we'll find it, experts, right? You notice that we'll find the title somewhere here, UN experts, Age Zambia 2. So the machine or the piece of software will see this, whereas you and I would see something like this. Okay? Anyways, what's important here is we are saying that web services or APIs, right? This is an example of application software. Okay? It gets better. These days, especially for services that are used often, it's quite common to build software using what's called a modular architecture, right? So to make it possible for additional features to be attached to the software by whoever is interested. Now this is an important point here, because it turns out that the piece of software that powers this piece, Core MIS, is a classic example of a software that is modular. So in essence, what they mean by modular architecture is, if the ministry right now, they've deployed this piece, this is this piece, if they realize to say, well, there's something off here, there's something missing from this software, this Core MIS software we're using, if they wanted to include an additional feature, they could extend the software, maybe through the creation of add-ons or something. Okay? Add-ons are a classic example of a type of application software. Now, you probably, in addition to add-ons, you've probably heard the word extension being used, right? Or plugin or something. I don't know how many of you have heard of this word, but it's quite common in when you're using, I don't know if you've extensively used Google Docs, for instance, right? In my case, when I'm using Google Docs, right, because of the nature of my job, and this is the essence of add-ons, right? The idea behind add-ons is they are typically associated with an application that can be used by different domains, or it can be used in different environments. Okay, so Google Docs. As a person that teaches for a living, I use Google Docs in certain unique ways, right? And I want to argue that the way I use it is completely different from somebody who is maybe an administrative assistant or something. Okay. In my case, because part of what I do is I publish papers and all those things, I can extend Google Docs, right, by attaching software add-ons. I don't know how many of you have used Google Docs add-ons. Like, for instance, I have an add-on that allows me to generate references, for instance. Okay? You're extending an already existing piece of software. It's a common concept, actually. The reason why a piece of software like CoreMIS, the software that powers this piece, would have to be implemented using a modular architecture is because it's freely available and open source, and hence a lot of countries, and within countries, a lot of organizations would want to configure it to suit whatever programs they would want to execute. Right? So you download extensions or plugins. Besides Google Docs, I don't know how many of you have used extensions in your browser, right? My Chrome, okay, or Chrome is a generic application. It's used by people in so many different contexts, right? There are certain things that I would want to easily do, which Chrome in its vanilla state will not enable me to perform those functions, right? So what do? I download what are called Chrome extensions. Okay? I have an extension here called a Google Scholar button, for instance. I have a ton of extensions, actually. If I click here, you will notice that the panel that comes up here lists all these different extensions that I have. Okay? Quite a number of them. Maybe if I say manage extensions, these are the extensions that I've installed, right? Or attached to Chrome to extend this functionality. And these things do so many different things. Like, for instance, what I was showcasing right now, this Lusaka Times, where is that? I don't know where it is, but when I was showcasing the Lusaka Times API, right? The structured data that I was showcasing, that is possible. I can see the structure of the data because I've installed a plugin. Okay, I have a ChatGPT for Google, for instance. I installed it early on when ChatGPT was installed. If I search MSP 5012, I don't know if I need to log in here. Because of the plugin I've installed, to the right here, there'll be a panel, right? A panel that also outputs information from like the information that I would get if I was interacting with ChatGPT. Okay, and I guess maybe I would have to probably grant this thing permission first. I don't know why I keep granting it permission. So that, whatever I'm searching in Google has corresponding results that come through from ChatGPT as well. If that makes sense. Close that for today. I don't know why this is taking long here, but this panel here, you will probably not see this panel because you have not installed this plugin. And in fact, if you've explored this further, you will agree with me that Chrome has what's called a Chrome Web Store, right? This is a place where you can get extensions, Chrome extensions. In fact, you extend Chrome in so many different ways. You can extend Chrome by downloading a completely different theme. You see, by default, this is how my browser looks like. But I can extend my browser such that I'm trying to see if I can use an example so that it doesn't look the way it looks like. I'll extend it using a dark theme, if you will. So if you notice, the look and feel has suddenly changed here. I'll just remove the extension because I don't want it. But the power is in the extensions. And really, if you go to extensions, you notice that you can look at extensions from so many different categories, right? Applications that are to do with lifestyle, right? Entertainment, games, and all those things. Productivity tools, right? educational tools, workflow and planning tools, and all those things. Anyways, yeah, hope this kind of makes sense. So the idea behind add-ons here is they are a type of software application that will provide additional functionality to an already existing application. So for them to work, they need an existing host application, much like how viruses work, right? They don't really work in isolation. They work by taking advantage of an already existing piece of software. Yes. Yeah, and really this concept of add-ons it's become so common now, such that these other popular applications like Microsoft Word, for instance, or Microsoft Office will is implemented, I think, using a modular architecture. Right? The same applies to a tool like the equivalent of Microsoft Office that I use is called LibreOffice. If you look at LibreOffice and I open LibreOffice Writer, which is the equivalent of Microsoft Word, and I go to tools, you'll notice that one of the things I have somewhere is here under tools. Somewhere at the bottom here is extensions. Okay, so I can extend the functionality of LibreOffice. Okay, if I say get more extensions, for instance, I'll be taken to a website that has a repository of these add-ons, if you will. And the beauty with this sort of approach is you don't necessarily have to depend on what other people have built as extensions, but you yourself can build extensions of your own. Okay. Anyway, so they require a host application, right? And really the word add-on, plugin, and extension, these are used interchangeably. Sometimes they're contextual, sometimes they're dependent on the type of application. Like for instance, in WordPress, okay, if we can, hopefully this example enable us gain a much better understanding of this notion of plugins, right? I just opened up my personal blog here, right? It turns out, right, that my personal blog and also the State House website, what else? And I think so, ZRA website, could be wrong here. Maybe not. So the State House website, right? I mean, if you notice, it looks, fancy and all that. It turns out that this is, and I'll confirm WP admin, see if I'll get to the login page. There we go. So the State House website, my personal blog, the ZRA website, they are all powered by the same type of software. It's called WordPress. And really, if you are interested, you can go out there and you can go and download WordPress and install it on whatever servers you'd want to use to host your website, for instance, right? So it's freely available and open source. Now, the reason why the same piece of software, WordPress, can be used to create something like this or something like this, and there are tons and tons of examples of this, right? Different sort of examples, is because it is built using a plugin architecture. So you can extend it, right? True to that, if I were to kind of log into the admin side of my my blog, you will notice that you may not notice this really, but you will notice that there's a provision for me to add plugins. Okay, I can develop plugins of my own, or I can look for plugins that already exist that I feel are best suited for whatever it is I would want to do. Okay, and then I would extend my WordPress. And really the extension, right, or enhancing the functionality of my blog here goes beyond just these microservices, right? The functionality itself. It's like you say, well, I want to have a strip where people can click and share content they find on the website, on Facebook, and all those things, right? Or I want to see a Twitch stream or something, so that whatever Lighton posts on his Twitter account is automatically synchronized to the website. Those are add-ons or plugins, right? But I can also extend this website by changing the theme, the look and feel. In fact, the theme is the reason why the State House website looks like it's completely different from Lighton's blog, but it's the same piece of software. And really, this is nothing new, right? The same applies to the UNZA website. If you look at the UNZA website, you may not know this, but the UNZA website runs off of a content management system called Drupal, okay? And as luck would have it, the University of Cape Town website, at least last time I checked anyway, is also powered by the same piece of software that UNZA uses. But if you look at the two websites, right, they look like they're completely different or something. The customization done was just different like that. Anyways, by the way, in case you want to look, maybe motivation for you to look more into things like WordPress, increasingly, those of you that have been following through with the developments at Smart Zambia Institute, you notice that at some point they started an initiative where they were setting up websites, right, for provinces, for provincial districts and all those things, and even councils, right? Last time I checked, I could be wrong, but these councils, so like Chipata City Council, chipatacity.gov.zm. What you may not notice is that there's Lusaka City Council, Chadiza. I don't know if the municipality there has a website. There we go. chadizacouncil.gov. You notice that there's a pattern, right? Well, I don't know yet, but last time I checked, they were using, if you notice, in fact, for for the councils, it's the same thing, is it? If you look at Chipata City Council and Chadiza Town Council, these things are more or less the same, right? There's a search bar top right, a horizontal menu bar here, and then the logo to the top left, right? Top left logo, top right search bar. And then there's a rotating banner here, is it? Same goes here, rotating banner here. It's one and the same, but they're changing the colors because the colors are different or something. This is WordPress, you know. Now you see, this is a part where you say, but Smart Zambia, why would you allow Chadiza City Council to use a Gmail account here? We should be seen to be serious with life. But anyway, I don't understand. Even Chipata City Council has a Gmail account. What? Okay. You know, in an ideal case, right, when you have, not that it's important here, but when you have something like this, right, chipatacouncil.gov, you should have something like mayor, right, at chipatacouncil.gov. Okay? Just like I think I noticed, there was an issue with one of our colleagues. I don't know if he's in attendance. Master, I think, has a dedicated, I don't know if there's a website here, but he has a dedicated domain, right? And I think the email he uses is master@chimbala.com or something. Now I don't know what I'll be shocked if he's not using WordPress here. Maybe it's Drupal or something, but it's probably WordPress here.
It's totally WordPress, Doc.
Oh yeah. Yes. Yeah. There we go. Oh, you're here. Yeah. So ideally, right? Ideally, I don't know why we're talking about this here, but I just wanted to mention that the councils, right? They mustn't be using this here. But anyway, so extensions, right? It's a breed, or it's a subcategory of application software. Extensions, add-ons, or plugins, as they're called. Okay. Anyways, And by the way, this issue of extensions is all over the place, right? So the UNZA, for instance, uses a generic application. I should use this as an example. It's called a repository. It's used to archive or enable access to scholarly research output produced by the UNZA. So if you want to find research, right, that the UNZA does, if you want to have an idea as to what UNZA does as an institution research-wise, just go to dspace.unza.zm. You find everything there, right? In fact, you will find dissertations, right? Dissertations authored by masters and PhD students. I have no idea if the long papers that you produce are archived here. They should be archived here. So if you do a bit of searching, you'll probably find them in the thesis and dissertation communities code, right? Now here's the thing. If you look at this application, this piece of software here, and you find them probably in humanities and social sciences or something, what you realize is that it looks like it's unique to UNZA because it's been branded and stuff, but it's the same piece of software as this. I hope it's online. It's usually offline. Now, Mamata uses the same piece of software called DSpace, right, to make available research output at the University of Cape Town, right? Now, if you notice, it looks different, right? Totally different. And the software services that you would find exhibited here would be different as compared to what's on the UNZA repository. But it's a piece of software. It's been extended like that, right? It's based on a modular architecture. Very powerful concept when it comes to computing, really. Although there are some downsides to using extensions, you're locked in somehow, right? If you download an extension and then the people that created the extension are no longer interested in maintaining it because there's no money to be made, you'd be faced with a situation where you'd have to look for an alternative. And I have found myself in such situations on numerous occasions here, because I like experimenting with a number of software applications. And I thought it would be nice also for us to just briefly talk about what we are seeing, right, currently, so-called AI models, okay? I mean, there's a lot of hype in regards to artificial intelligence. It turns out that we can view them as, artificial intelligence models can be viewed as a category of application software. So there's this notion that we can actually teach computers, right, to mimic what a human being would otherwise do. And really, if you look at artificial intelligence, there's so many different subclassifications of AI, right? So things like computer vision, we haven't really seen a lot of that in Zambia. I don't know if I mean, I've not heard of anybody driving a Tesla, for instance, right? That's computer vision. The fact that you can build a piece of software that would mimic what a human being would see when they're driving a vehicle, right? So you have autonomous vehicles or self-driven vehicles, if you will. But also this field of robotics, right? There's a bit of computer vision there. But there's more. There's issues to do with natural language processing. Some of the things you've probably seen or something, if you watch a lot of YouTube, you agree with me that in some instances where the comment section has a lot of comments, they'll be automatically grouped somehow, right? So the idea behind that is that similar to Facebook, similar to YouTube, I can use Facebook. If you visit pages like popular pages like I want to say is it Zambian Watchdog, for instance, right? It's not feasible. I mean, unless if you have nothing better to do in life, yeah, it's not feasible. Like this thing that was posted that it was raining apparently heavily in Mbala or something. There are 704 comments, right? Well, I mean, who has the time to read all the 704 comments? I mean, I know I don't, right? Maybe there are people that can do that, but we can take advantage of so-called natural language processing, which is sub-classification of AI, right? To maybe do a bit of topic modeling. Say, we are going to group these comments based on whether a comment is useful or not useful or something, or whether it's spam or not spam. Some of these comments would be just people tagging other people, right? At Lighton, so that I'm notified and I go and watch this video or something. So there's AI models, and AI models do so many different things. We can sit here and point at specific examples, or maybe things that can be localized within the Zambian context. There's a project we're working on. It's called I don't know if I introduced this when I was introducing myself in the very first lecture here. There's a second lecture when I had introductions. But there's an enterprise medical imaging project, right, that we've been working towards with colleagues from the University Teaching Hospitals and the University of Cape Town. And part of what we're doing is we are building, or we've been experimenting with building AI models that are meant to help radiologists to interpret medical images, right? So when you're sick and they tell you, oh, go and get a CT scan or an MRI or an X-ray or something, it turns out that a radiologist, an expert radiologist, is supposed to get that image after examination and interpret it, right? So they'll literally go through the image and try and check if there are any abnormalities or something, and then afterwards they'll prepare a report for you and then say, take it back to the referring physician. Well, there's a bit of a problem in Zambia, right? As of 2019, there are only 5 radiologists, right, against a population of about 17 million or something. So what we're doing is we're building AI models to automatically interpret medical images or something like that, right? So anyway, so there's this new breed of applications called AI models. We can call them AI models. And perhaps the more common things that we've probably experienced firsthand are these so-called large language models, right? Generative AI models like ChatGPT and Meta AI or Gemini or something. Generative in that it actually mimics what a human being would do or how a human being would respond, right? If you asked them a question. Only these things are so generalized that they can answer virtually any type of question, if you will. So anyways, so we have this breed of applications called artificial intelligence models. We can call them that. And this is the future, really, right? If you look at your phone, you have things like Smart Compose in Google Docs, in Gmail. When I don't know how many of you have experienced this, but you find yourself writing an email if you are wanting to write an email, like in my case. I don't know, it's not going to come up here. But as you're typing an email, if you're connected to the internet, it's almost as though Gmail knows exactly what you're going to type next, ideally, right? So anyways, so AI models, right? But besides that, there's also, I guess, what one would call esoteric application software, right? These are scripts, for instance. These would typically be used by individuals that are more technically inclined, so systems administrators, right? They're meant to help perform repetitive tasks, sometimes ad hoc tasks. So I'll give you an example. One of the things a system administrator would want to do is, if they're running an application or if they're managing an application like ZSpace, is they would want to maybe regularly check how much memory, right, is available, or how much space is available. Instead of logging on to ZSpace and typing commands, right, utility software commands like df -h, there's just 2 GB left here. What they can do is they can write scripts. And you can write a script that can automate this whole process of checking space and telling you to say, when the space is above 90%, you have an email automatically sent to you, or an SMS or something. Okay? Those are called scripts. In comparison to more complex software like ZSpace, these are really small software programs, if you will. Just a few lines of code. Okay? And generally speaking, these typically be used by IT personnel, if you will. Okay? It gets even better, right? There are so-called libraries and frameworks. If you remember, when we're discussing the process that one goes through, that you'd want to go through when you're building an application like ZSpace, we say that you typically go through 5 phases, right? requirements analysis, so requirements engineering, design, implementation, testing, and evolution. Well, it turns out that during implementation, when you have programmers writing or creating the software, this is a task that it can be quite involving, or it can actually take quite a bit of time. And so over the years, what smart people have done is they figured out how this process can be shortened, if you will. Okay, and so application software, code, libraries, and frameworks or modules have been created. So this notion that if you're creating something like this piece, give an example of this. If you're creating a piece of software like this, one of the things one of the things we know is that an application like this should have a provision for people to log in. That's a given. An application like this, because it's web-based, is going to have like an interface, right? A user interface, which will have buttons and text boxes and combo boxes and radio buttons and check boxes and all those things. Well, if those things are applicable to a broad spectrum of web-based applications, if not all of them, then why do we have to redo them every time we're building such applications? Well, we don't have to, which is why frameworks have been implemented. Okay? So you have all sorts of frameworks, like web frameworks, right? Or sometimes they'll be called front-end frameworks or something. Those front-end frameworks are specifically meant to help create the user interface. Like if one wanted to create an interface that looks like maybe Facebook or something, they would use React. Right? The React framework or something. Okay? If I wanted to build an interface that looks, I can't really give an example here, maybe the Unza website, I would use Bootstrap, right? Bootstrap web framework or something. So it's a starting point. You can view these frameworks as like a starting point. Instead of you writing code from scratch, there's a reference point, right? A starting, much like if you say you're building a house, you have the choice of, and I hope this example will help explain this notion of frameworks and libraries. If you're building a house, you have a choice of making your own bricks, right? In fact, if you want, you can go and make your own cement. That would be crazy though. Maybe there are people that do that. You make your own cement, you make your own bricks, you make your own iron roofing sheets. But what is faster and what is effective is you go and buy bricks, right? Well, I mean, if you want to, you can go and buy cement and then you make the blocks or something, right? You go and buy your roofing sheets and then you build your house or something. The other option is you do everything from scratch, right? So the same applies to software. You can take advantage of already existing software libraries, frameworks, and modules, right? So that you are more effective and efficient when you're building software. And true to that, really, if you look at the way core MIS was built, if we look at the resource we've been making reference to, I should probably download this or something. What you realize is that if you look at core MIS, what you realize is that I hope they explained this. No, they don't, but it's unfortunate that they don't here. Trying to, they don't mention this, but you notice that there are things like, there's a starting point. Okay, the components that are being used here, but there are things like this thing, Spring Boot. I'm not very familiar with Spring Boot, but Spring, I'm sure it's a framework. Yep, if you notice here, right? Spring Boot is an open source Java framework, right? Yeah, so there's a starting point. For them to build core MIS, they did not build core MIS from scratch. Okay, there are frameworks and libraries that were used. In fact, because we know that this thing was built using Java, we know that there were libraries that these people were using. In fact, look at this. In the front end, they're using jQuery, a library, right? Like the interface, the front-facing part. They're using Spring Boot theme leaf, they're calling this. I've not used this before. It's a framework, just looked it up. Spring Boot, Jasper reports, right? It's a starting point here. I don't know if it's a library here or a framework. It's probably a library, I guess. But again, it's a, let's see here. It's just a reporting tool. Yeah, it's just a reporting tool. But again, the idea behind using libraries, frameworks, and modules is you're trying to reduce the amount of time you're going to spend developing software by reusing components, right? So it's going to be best perceived as being reusable software components in essence. Okay. Anyways, and then now some of these may not really explicitly come up when we start discussing subsequent modules, but they may we may just touch the surface, especially when we come to implementation, right? Because there's a dedicated discussion later on where we discuss how exactly is this built. Okay, what do you need to have in place for something like this to be built or something? Okay, and believe it or not, in addition to so-called libraries and frameworks, malicious software is application software. Now, I want to draw your attention to a very important definition of application software. We said that application software is a type of software that allows end users to perform specific computing problems. Okay, if you look at malicious software, like if you look at ransomware, right? It is application software because it is designed to perform or to solve, help address a specific problem. In this particular case, it's meant to help somebody to encrypt somebody else's data and then request for a ransom, right? We will not decrypt your data unless you give us money or something. A virus is application software. Why? The specific problem it solves is it corrupts, right? Normal software, ideally. So anyway, so what we are saying here is that malicious software, all the broad spectrum of malicious software applications, and there are a lot of them. Again, in module number 7, we have a detailed description of these malicious software applications because they're quite relevant to our discussion of social protection management information systems like ZSPIS. There's money involved there. If there's money involved, people may want to infiltrate your network so that they gain access to the server that has ZSPIS, and then they start adding illegal beneficiaries or something. Okay? Somebody may want to illegally gain access to ZSPIS so that they cover their tracks, right? If they realize that somebody is onto them or something. Okay? Somebody may illegally want to gain access to ZSPIS so that they spy, right? They start monitoring what is happening on the system, spyware. And really what you begin to realize is that there's a whole types of malicious software. There's a whole slew of malicious software. And I think we have a discussion of the popular ones, right? I guess the ones that are relevant to our discussion of an application like ZSPIS. You know, would want to discuss ransomware so that we try and avoid what purportedly happened to, what do you call this? ZRA, is it? Sorry, NAPSA, right? When apparently their servers where data on their servers was encrypted or something. You know, so there's quite a number of malicious software. The key thing here is malicious software is a type of application software. I think there should be enough context, rather, or information to make you appreciate the role that application software plays, especially insofar as social protection management information systems are concerned, right? I'm going to pause here and just maybe ask if people have any specific questions about application software. Yeah. Um, maybe just to try and put certain things into perspective here, right? If we were to look at this piece relative to the things that we're discussing here, right? We see that if you look at this piece, right, it's possible that some mobile application like a browser could be used, right? Like if you're using a tablet or even your phone to access this piece, right? So you'd find yourself using mobile application. I don't know about USSD based USSD applications here, probably not. I don't think there's a dedicated mobile app for this piece. Maybe not. And then in terms of desktop applications, one would argue that if you're using your browser, right, your desktop browser, for instance, you're using a desktop application because you downloaded Chrome or Firefox to install it, right? In fact, we can distinguish this by saying client, and then here we could say on the server or something, okay? What else? Web applications. Well, this piece itself is a web application. Right? This is a web application. Web services. We see that mobile service payment gateway is a web service, right? I don't know how much of this you remember, but there was a time when we said that the way this piece is implemented is for money, right, to be dispersed via this piece. This piece has got to interact with services such as MTN mobile money, for instance, okay, or Airtel mobile money. Now, this piece just doesn't directly talk to Airtel or MTN money, right? It talks to these applications via an API or web service. This is why this diagram has Airtel API, or this could just as well have been Airtel web service or something like that. Okay. Anyways, and then also if we look at things like, let's see if we can go through all the different types of application software we're discussing here. So as web applications, add-ons. I don't know here, right? I would only be speculating here. I know this piece is built using a modular architecture, but so we could say maybe, but I can't think of like a specific add-on, right, that's associated with this piece. In part because, you know, CoreMIS is a relatively new application. In fact, if you look at somewhere on the, I think somewhere on the website, the World Bank website, they have a map, right, of I guess places that have adopted CoreMIS or something. But anyway, it's neither here nor there. So extensions and add-ons, AI models. To the best of my knowledge, I would say this is questionable as well, unless if the ministry, for instance, has deliberately built, you know, applications or AI-driven applications or services that are interfaced with this piece. Okay. In terms of scripts, maybe the administration part. So administration of this piece. So there are people in IT department, in the ministry's IT department, that manage the server that is used to deploy this piece. Okay. In all likelihood, they use scripts for them to do that. Libraries and frameworks, we just looked at this example. So when implementing this piece, a number of libraries, right, like jQuery, Spring Boot, were used ideally. Okay. Yeah, I mean, malicious software. No, I don't think I can think of an example here, unless if the ministry would report to say, well, on such and such a time, our servers were attacked, right? And this is what happens. And usually, organizations will not will not tell you that they were attacked or hacked. Will just say there was a system failure or something like that. I don't know. I mean, I hope this is a good enough outline of what application software is all about. And unless if people have questions or something on application software, if not, then I suppose we can proceed and look at the other category. If you remember, when we introduced computer software, right? And we said that computer software, in essence, directs the hardware on what to do. Also, we underscored the importance of categorizing software, right? We realize that software comes in two broad categories: the so-called application software, which is used to perform specialized computing tasks like word processing, okay, or emailing or something. Well, system software, in essence, the role of system software is to coordinate and manage hardware and application activities. Okay, and I think this definition is best perceived from the point of view of one of the most widely used, or not really most widely used, but system software that most of us can relate to. Operating system software. You know, before you can use your phone, you need to make sure that you have an operating system installed, is it? Or Android or iOS or something. Okay? A Windows Mobile. I don't know if it's a Windows Mobile, it's still a Windows Mobile operating system here. But anyway, so what system software does in essence is it coordinates and manages hardware and application activities. And this obviously makes sense, because if you remember, we said that in as much as we use application software most of the time when we want to tell the hardware what to do, but application software does not interact with the hardware directly. It goes through, in most instances, it goes through system software. Okay? So whenever you're using Microsoft Word, what you're doing, whenever you're using Microsoft Word or Gmail or this piece, you're just telling your hardware what it should do. But the application you're using does not interact with the hardware directly. It goes through system software. Okay? Now there's an important point here, right? The fact that the role of system software is to coordinate and manage two things: hardware and application software. Okay, the last part here is the reason why we've been saying and singing the song to the effect that application software does not directly interact with the hardware. It must go through system software. So system software is essentially there to coordinate and manage application software activities and hardware. You see, the hardware bit here is pretty straightforward, right? It will manage things like if you're using a computer, like right now, in my case, I have a wireless mouse connected. I have a microphone connected, right? I have a router. All of these are, dedicated hardware or peripherals, right? The question to ask is, how does a computer know how to manage all these different things, right? Because they are all interfaced with the same computer system at the same time. System software does that, and specifically in this particular case, it will be operating system software. Okay? So that's the management part of the hardware. And we imagine the hardware involves a number of other things here, right? Like you can configure your hardware such that it behaves in a certain way, is it? Like in my case, when I've configured my computer in such a way that if I only have 5% remaining in terms of battery power, it must gracefully shut down so that I save information. That's the hardware configuration. Okay? And then the part where we're saying system software coordinates and manages application software should make sense, right? Because if you look at the typical person who is interacting with a computer, you agree with me that you probably have a range of applications open. Like in my case right now, I have LibreOffice Writer. I have Firefox open. I'll close it now. I have I have Chrome open. Okay. I have Dolphin, which is a file browser, open. I have the KCalc application, which is a calculator, open. The computer needs a way of managing how resources are shared amongst these different applications. And the thing that does that is system software. Okay? And again, within the context of the example I just gave here, operating system is what does that. You know? Anyways, I guess another point worth mentioning here, relative to what we've already discussed, is that from the perspective of what languages are used to implement software. If you remember, we said that when software is being implemented, there's a choice to either use high-level instructions, right, the top here, right, or assembler instructions, assembly language instructions, or even binary instructions, ones and zeros. Well, it turns out that typically when you're implementing application software, you use high-level languages or programming languages, but when you're implementing system software, you will find yourself using low-level languages. Okay, because the interest here is to optimize key functionality of system software of managing hardware and application activities, in essence. Anyways, and also just to mention here that system software, in fact, this also applies to application software, is generally implemented for specific hardware architectures and CPUs. So when you look at an operating system like Android, it is meant for mobile devices. You cannot install Android on your laptop, at least not that version of Android. I know people have created ports, what are called ports, right? Okay. So there's that, I guess. And then we see here that there's some crucial system software that would generally be pre-installed on a computer system. In most instances, right, when you buy a new computer, there will probably be an operating system there. If not, at a bare minimum, the system software that will be installed there is called firmware, right? The black window that you see when you switch on your computer, you see a lot of text come up, right? In some instances, when you press certain keys, you find yourself in what's called the basic input and output system, the BIOS or something. I don't know if let me see here. I don't know if people know what I'm talking about here. I'm trying to see if I can find let's see, BIOS. I don't know how many of you have seen this course I teach, and I don't know how many of you have seen this happen to your computer, right? I guess it's fine here. So when you switch on your computer for the first time, you would see this, right? What you're seeing here is what's called the BIOS, right? It's a firmware. Okay, and it's the one that's responsible for bootstrapping your operating system, loading it in essence, so that you start interacting with your computer, right? So all of these things are associated with the BIOS, and the BIOS is a classic example of system software, right? Besides bootstrapping your operating system, obviously it helps with things like helping with diagnostics. So if you want to check if your hard drive is working fine, or if there's something wrong with your RAM or your CPU, you can use a BIOS to do that. But anyway, that's neither here nor there. That's fine. And it turns out really that there are, and by the way, I hope as we're discussing this, you remind yourselves about why we are having this conversation, right? We must link this to ZSpace. Like for instance, we need to make sure that an operating system software is installed on the server before we can install ZSpace or use ZSpace. There has got to be firmware. language translators are used when building ZSPs. Utility programs are used whilst managing ZSPs and all those things. So it turns out that there are three broad categories of system software, okay? Broadly speaking, you can say four here: operating system software, there's firmware, the language translators, and utility programs. Or we can just lump operating systems and firmware together, because, or maybe we can distinguish them, right? So there's operating system software, there's firmware, there's language translators, and utility programs. Now, utility programs really are generally used to monitor and manage computer systems. And probably the most common utility program that a lot of you have used is Task Manager on Windows. You know how you click on Control-Alt-Delete on Windows, and there's that pop-up window that comes, and it enables you to end programs that are not responsive, right? If they're not responding, so that you're able to use your computer or something. That's a utility program. You use it to monitor and manage a computer system. Okay? And there are a number of such tools, really. Like, I don't know how many of you have used computer management, right? The utility software tools. There are likely utility tools that you use to add a printer to your computer, so that your computer is able to be linked to a printer, so that you can print whatever documents you want printed or something. Now, the monitoring and management of computer systems is especially important when we look at, remember, if we look at a social protection management information system like ZSPs, there are two types of computers that we are dealing with. They're called client machines and the server. The thing that you find yourself monitoring and managing often is a thing that is accessed by a lot of people, the server computer system. In as much as utility tools are really associated with both, microcomputers and server computers and mini computers, mainframes, embedded computer systems, but within the confines, within, I guess, the context of us discussing MSP 5012 and especially social protection management information systems, we're saying that these are especially relevant when we're dealing with server computer systems. So computer systems that are used to host social protection management information systems. And what you would do with utility software tools when installed on such server computer systems is you would be monitoring and managing that server computer system. Like, for instance, you are monitoring and managing the functionalities of the computer system that will facilitate input of data, processing of data, outputting of processed data, and even storage. And what you notice here, all of these four things can be mapped onto the core functionalities of, I guess I'll say, a management information system. Input summarized data, process the summarized data, and output information. So really, these are things you're monitoring, right? Granted, I mean, in some instances, you could be monitoring other system software here. Anyway. And again, this is the point I was talking about, to say, for the most part, you do have utility software tools that you will find on microcomputers, like antivirus software, for instance, and tools like Task Manager and all that. But for the most part, the thing that needs constant monitoring is a server. And this makes sense, right? If you remember the key functionalities of the server, reliability and availability. If you are to guarantee that the server that is hosting ZSP, so if you are to guarantee that ZSP is going to be available 24/7, you have got to employ somebody in IT, pay them a lot of money here so that they are on standby. And part of their job is to check continuously the health status of ZSP. Is it up and running? If it's not up and running, you use utility software tools to debug and find out why it's not up and running. Is it functioning optimally? If it's slowed down, then they'll use utility software tools, right, to fix that. But anyway, so you're monitoring and managing again here, monitoring and managing server computer systems here, right? And really, I'm just in the subsequent bullet points here. We're just talking about the same server functionalities, right? Like for instance, we see that servers or services provided by servers can be accessed by a lot of people, hundreds, thousands, sometimes even millions of concurrent connections or people at the same time. Think of Facebook here. If that's the case, then you'd want to monitor that the server computer resources are being used optimally. The server is not slowing down or something. And then in terms of availability here, we see that a number of services provided by server computer systems are supposed to be available all the time. I do hope ZSpace is one of those examples. At any given point in time, people are using ZSpace, maybe except when people go on during their December break or something. But this system needs to be available all the time. Okay? And then we see here that because server computer systems will typically be used to host critical services like core banking software. Okay? You don't want people to be unable to withdraw money or something because the system is down. Or you go to, I hate it when that happens, you go to Silverest to go and renew your driver's license, and you go there early in the morning and they tell you, oh, there was a brownout, and then after the issue of power was addressed, the system has become slow. Right? When it becomes slow, it's unfortunate that the number of these entities in this country, this enterprise we call Zambia here, we haven't really, we don't take service provision seriously, right? And I say this because usually the system is down is an excuse that is given, but it's not supposed to be the case, right? Or the system is slow. It's not supposed to be the case. You know, you're supposed to make sure that you have, I guess, proper server computing infrastructure in place to make sure that those problems are addressed, right? In addition, you want to make sure that you hire competent people that are able to debug and address these problems when they arise. Okay? So the experienced or competent systems administrators will use utility software tools to optimize the performance of the server. Whenever there's a report, right? The system is down, you call IT. The system is down here, we can't work. People in IT will use utility software tools, right? To pinpoint what the problem is and to fix it. Okay? So it's utility software tools. And then you have language translators, right? In essence, language translators are system software tools that will convert source code or a programming language into a functional equivalent code, right, in a different language. So a nice way of thinking about this is, as the name suggests, you're translating, right? It's like, I use an example of what typically happens when you're developing software. You see, when a programmer is creating software like ZSpace, what a programmer will do is they will use a programming language to write source code in ZSpace, or ZSpace source code rather, not source code in ZSpace. After they are done writing the software or creating the software, they will package it. They will package it in such a way that the output will be something like zspace.exe, or it will be zspace.msi, I think. Or in the case of Linux, it will be zspace.dev or zspace.rpm. In essence, these things on the other side of the arrow are called binary files. These are the things that end users will interact with. Now, for you to get to a stage where you move from source code to this binary file, you need a language translator. It's a thing that's going to convert the source code into its functional equivalent notation. And in this particular case, you may not know this actually. Typically, when you're converting from source code to .exe, you're converting from a high-level language into its binary equivalent, like ones and zeros or something. If that makes sense, right? This is why you need language translators. And really, there are different types of language translators. I mean, we don't really have to go into the gory details of the different types. For instance, when you are wanting to convert, if we go back here, by the way, if you are writing software, let's say like WhatsApp software, you typically use a high-level programming language, right? And then for you to come up with the output itself that's going to be installed, you'll probably convert it into binary or something. So these examples of language translators that we have here are relative to the different notations. If you want to convert from assembler instructions into ones and zeros, you'd use an assembler, right? If you want to convert from ones and zeros to assembler, you use a disassembler or something, okay? And then depending on whether you're using an interpreted language or a compiled language, you find yourself using an interpreter to convert or to translate high-level language into machine-readable instructions, okay? Or a decompiler for the opposite of what a compiler does. So language translators. And within the context of ZSPIS, what we are saying is, if we go to, I don't know where that is here, but this is the code I was talking about. But if we go to here, by virtue of the fact that you're using Java, you would need a translator, right? Like you'd need a Java compiler, to convert your class files into your .java files into .class files or something. So implicitly, we are using, and this is, I think, a point that needs to sink in here, is the fact that in most instances, not all the time, but in most instances, this breed of system software called language translators are used when you are building an application like ZSPIS during the development. So observe, if we try to tie this to the SDLC cycle here, the development is taking place during implementation. So the translation takes place after you test and you say, oh, this is fine, this is what we wanted. You want to convert the code into something that users will download and install. Okay? Hopefully this is making sense here. So in addition to, remember I say you teach software tools, there are language translators. You also have firmware. I think I already had briefly introduced firmware, right? These are nothing more than low-level instructions that are aimed at controlling specific hardware. And usually, right, at a bare minimum, firmware will be associated with it's typically any type of computing hardware. But it's especially relevant when it comes to single function devices like embedded computer systems. So the ZESCO customer interface unit that I was talking about, that gadget we use to enter the electricity units or something, and to maybe I don't know what else people do here with the ZESCO customer interface unit. I know in my case, I'll normally use that embedded computer system just to recharge, right? And the recharge has been made simple. Previously, I would have to enter a combination of keys, even special characters like hash. But now I just enter that code, okay? And then boom, the magic happens, assuming I enter a valid code here. It turns out that those type of computer systems are associated with low-level instructions. There's no operating system there. Why? Because it's a single function device. It doesn't need to be generalized. If you think about your laptop, right? You can use a laptop. If you have a spouse, maybe your spouse can use that same laptop by installing software that they would want to use the laptop for. Your phone can mutate into so many different things based on the software that you are using. It can be a communication device if you're using WhatsApp. It can be a word processor, for instance. Now, I'm saying this to highlight the fact that there are certain types of computer systems that are there to perform just a single function, like the ZESCO customer interface unit. There's nothing like, you cannot use that for anything else other than just recharging and checking if you have enough units. That's it. So if that's the case, all you need is just one dedicated piece of software. It's called firmware. Okay? And its role really is just to control the hardware that it's associated with, typically created using low-level instructions here. The example I gave here was the basic input-output system. The basic, it's not BIOS, it's BIOS. Basic, so it's BIOS, basic input-output system. Each and every one of us has probably seen this. When you first start your computer, you see a whole bunch of text. That is firmware called the BIOS. Okay? Anyway, and in the case of ZSPIS, we see that firmware is associated with both the microcomputers. I don't know if it's there here. It's associated with both the client computers that we use to access ZSPIS. So there's firmware on your laptops, tablets that you're using to connect to ZSPIS, desktop computers, okay, even smartphones. And then there's also firmware on the server computer system. Okay? If that makes sense. Okay, so firmware, and then we have operating system software, right? Ideally, operating system software is typically installed on general purpose computer systems, and the role of operating system software is to manage computer hardware and application software. I think I already mentioned this and gave examples at the very beginning when we were introducing system software. And really the definition, or our definition of system software, is best understood from the point of view of what an operating system does, really. Right? So it will control the operation of the computer. Okay? Those of you that are left-handed will agree with me that at some point you had to use the operating system to tell the computer to say, I want the default left button for the mouse to exhibit functionalities of the right button, because your mouse will be on your left hand side of your computer or something. Okay? I want my computer to behave in a certain way because of load shedding. Now I don't want to lose my data when there is 20% remaining, 20% power remaining. I want the resolution to reduce because it eats up a lot of power. Okay? And you do this with your smartphones as well. If there's 5% remaining, please put the computer in sleep mode, so that the state, the things I'm working on right now, everything will be saved into RAM, and then power will be conserved. I won't be able to use the computer, right? So that I don't lose important data or something. What you're doing is you're using the operating system to manage the computer hardware. But you also use this to manage application software. And now the management of application software will generally be implied. It's an implied function for the most part. So behind the scenes, remember you have limited compute power, right? Like I have 31 GB of RAM. The question is, when I have so many things open, and you've experienced this, right? Or maybe they've told you, IT, you call IT, the computer is slow. What do? They say, close some of your windows or something. Well, you are somewhat trying to make optimal use of the finite resources you have access to, like RAM, for instance. But it turns out that the management of how this RAM is used is done by the operating system in the background. Whenever you have a lot of applications open like this, the operating system has to decide on how much resources are going to be allocated to the different applications. In addition, a computer has finite CPU computational power, right? So the question is, how is this CPU power allocated to these different applications, right? The operating system does that. Anyways, also there's a crucial function that the OS does. It provides end users, right, with a mechanism of interacting with hardware and application software. You see, when you say I'm using my computer, right, you see interfaces, right, buttons and all that, the screen. Well, this is what we're calling the interface. Okay, if I were to the interface, like those icons that you see on your desktop or something, the my computer icon, that is the operating system. It's providing you with an interface to interact with the computer hardware. And again, really, right, if we were to contextualize this from the perspective of ZSPIS, we see that we need an operating system so that we can interact with ZSPIS on client machines. On the server side, there has got to be an operating system, right? So that whoever is managing the server computer system can interact with the server computer system, ideally. And really what happens behind the scenes is the operating system is like any type of software. When you install it, it's located somewhere on your internal disk, right? So when you start up your computer, part of it is bootstrapped, it's loaded into RAM, and then the magic happens, ideally. Anyway, so it turns out, like we mentioned here, the system software actually gets to, because of its function, or implied function to coordinate and manage hardware and application software, we see that system software directly interacts with the computer hardware. So all of these things we're talking about, right? Operating system software, firmware, and utility software tools, they have direct access to the hardware. Okay? And because of the role they play, they're supposed to be implemented using low-level languages. Anyway, just to mention here, right, irrespective of whether we're talking about application software or system software, we see here that they are crucial, right? I was giving examples. They're very crucial in implementing effective information systems or management information systems. Implementing and deploying, in fact, implementing, deploying, and using. Because for a social protection management information system to be effective, you need to have utility software present. You need operating system software, for an MIS platform to run. Okay? You need application software. In fact, the management information system itself is application software. And really, another interesting way of looking at system software is we see that it provides you with the platform. If you remember, this word platform came up when we were looking at cloud-based services, right? So it provides you with the best platform that is used to run application software such as your ZSPIS or something. I hope that's a good enough overview of software, computer software. I'm going to pause here and find out if people have specific questions, I guess. I was going to suggest that I see here there's about 17 minutes remaining. Just to give us, I was going to start the next aspect here, but we can look at this when we meet on Sunday. But to give us an idea, remember we emphasize the importance of the communications infrastructure, right? The fact that you need a communications infrastructure for you to gain access to resources on a network. Like for instance, for you to access this piece, you need to have access to the internet. when you don't have access to this piece, maybe IT will tell you, oh, the internet is down and we're working on it or something. Okay, so we're going to discuss, although at a very high level, this notion of communications infrastructure, and really our discussion is largely restricted to computer networks, so that we have an appreciation of what it means when somebody says, well, this application will only run on our intranet. If you are not on the intranet, then it won't work, or something like that. Okay? Or what it means when somebody tells you, we need to set up, there's a new district that has been set up and IT is still busy setting up their local area network, which is why they are unable to use this piece. We understand all of those things here. And in the process, all the while, hopefully, we'll be able to link these concepts we'll discuss to this whole notion of social protection management information system. I want to pause here and again ask if maybe people have any specific questions about software or anything that we've discussed so far. If not, I was trying to see if maybe we can already put up an assignment, or maybe we should wait until we finish this module. Maybe not, I don't know. But be on the lookout. Once this is done, communication will be sent out to the course rep, but also via the mailing list. All right. If there are no questions or thoughts, thank you very much. And I'm hoping that, not I'm hoping actually, I think we have class on Sunday. Just a reminder. I think we may have caught up here because I'm here to get feedback, but I think that could be wrong here, but I think it's 3 hours per week or something, unless if I'm mistaken. It could be an error on the timetable, but I'll wait for feedback from the head of department or the coordinator. All right, if there are no questions, thank you very much, everybody, and we shall. I don't know how I had stopped sharing here, but we shall continue this discussion on Sunday then. Bye for now.
Bye. Thank you, Doc.